Hey guys, so today we're going to talk about factoring polynomials. The purpose of factoring is to help us find the x-intercepts of our polynomial and where it actually crosses that x-intercept. So it's good to know how to do it because then you can find it without even using a graph. So there are a number of different ways to factor polynomial expressions. It just depends on what you have. So the strategy you use may depend just on which type of expression you have. So I'm going to look at a few of them. The next lesson is going to look at a particular one, but hopefully you get some strategies here on how to factor some different polynomials. So the first one we're going to look at is one that's mostly just the greatest common factor. And every time you factor, this is the thing you're going to look at first. So I'm going to go through one of these examples. When you're looking for the greatest common factor, you're trying to find what is similar in all terms. Now, when we look at this one, what I want to do is look at what's similar between the coefficients, so that the numbers that are in front, what's similar in the variables and their exponents. So in this case, I notice that we have an 8 and a 12, and I know that 4, they can both be divided by 4. So you're looking at what can they both be divided by. They both have x's. One is x squared and one is x to the 4. So when you do this, you always want to take the one with the smallest, so x squared. And then they both have y's. This first one has y to the 3, and the second one has y to the 1. So I'm just going to choose the y to the 1. Basically, then what you're going to do is divide both of those terms by 4x squared y. And we're going to use our exponent rules and whatnot to do this. And so what you get is 8 divided by 4, which is 2. X squared divided by x squared is just 1. We'll just get rid of that. And y3 divided by y leaves us y squared. The second term, 12 divided by 4, gives us 3. x4 divided by x2 gives us x2. And y divided by y is just 1, so we'll get rid of that. So this is what's left. So we can now write this expression in factored form to look like this. X squared y, 4x squared y, because we divided by that, we pulled it out of both terms. And then whatever's left, 2y squared minus 3x squared. You can check these, just multiply it back out, and if you get the same thing, it means you've done it correctly. So that's common factoring. You should be familiar with this because probably done it before, but I just wanted to go over that. Another thing to factor is what I call factoring using factors of c. Now, when I mean that, I mean when we look at the polynomial function, especially if it's a second degree or a quadratic, that's what it's called. What I look at is what are the coefficients, and I label this one A, this one's B, and this one's C. So what we're going to do is we're going to try to find factors of C that also add up to B, which in our case is 10. So we're going to find factors of 24, but they also have to add up to 10. So if I think of factors of 24, a couple come to mind. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, and you can list them all. Because it's a positive 24, you might also list the negatives. So don't forget about those. Especially if your number is like a negative 24, you're going to want the mixture of the pluses and minuses because it's basically whatever gives you that plus 24, and so on, etc. But what we want is a positive 10. So even from these first ones, I can see that 4 and 6, if I add them together, I also get 10. So 4 times 6 gives me 24. And 4 plus 6 equals positive 10, which is what I'm looking for. So these are the numbers that I want. Now, once you have those two numbers, 4 and 6, it's super easy because a is 1. Super easy to factor. It becomes x plus 4 and x plus 6. Again, you can multiply it out. You can check it to see if you're right by multiplying it out. Gives me x squared plus 4x plus 6x plus 24, x squared plus 10x plus 24. And I get back the same thing as what I started with, so I know that I am correct. So sometimes the factoring is not that simple because we have a number in front of our a value. So this happens when a has a value in front of it, a, b, and c. So what you're going to do is you're going to multiply a times c, which in our case is 6 times 1, so it equals 6. And then you're also going to find, factors of 6, but also add to b. Sorry, that's a 6. This is the letter b, which is, in our case, -5. So we want two numbers that add up to 6, or multiply to give us 6, but also add up to give us -5. So if I start thinking about those, I'm going to do them in a different color. Our factors of 6 are 6 times 1, -6 times -1. They both work. 2 times 3, and -2 times -3. Those are all of them. So the idea is to then find the one that equals -5. And if I look really closely, -2 plus -3 gives me -5 as well. So those are the two I'm going to use. But what's interesting about this one to make it kind of how we want it is we're going to do what's called decomposition. So we're going to split that -5 into the -2 and -3. So it looks like it's going to look like this. So we have 6x squared. I'm going to do -3x minus 2x and plus 1. So notice how if I were to put these two together, I would get the -5. So I'm just breaking that -5 apart into our -2 and -3. So then what happens is I kind of want to treat these two together and these two together, and I'm going to factor each one of those. So what I can grab, or common factor, from the 6x squared minus 3x is 3x. And then what I have left over, 6 divided by 3x, is 2x. And 3x divided by 3x it's our -1. And then we're going to do the same on the other side. Sorry, guys. I don't want that there. So -2 plus 1. I'm going to pull a -1 out. And -2 divided by -1 is just 2x. And +1 divided by -1 is -1. And so what you'll notice when you do decomposition like this is whatever's in the bracket is the exact same thing. So what we can do is factor that out, the 2x minus 1 as a factor, and then whatever's left over is 3x minus 1. And that gives us our two factors for this one. So that is how you factor by decomposition. It's a bit more complicated. I'm probably going to try and find you guys another video about this in case this one is a little bit fuzzy. Let's move on to the second page. So let's quickly go through some of these examples. If you need to see them again, it's okay. Pause the video, go back and watch me do them again. I want to get through most of them. So let's see, A is 24x squared plus 30x plus 6. So right away, I see there's an x in each one of them, and I know that they can all be divided by 6. So I'm going to pull a 6x out of each of them, and then I'll see what I have left over. So 24 divided by 6x is 4x. 30x divided by 6x is 5. And the last one is just a -1. And so this is it. I can't do anything else with it, so I'm just going to leave it like that. B is kind of like one of those decomposition ones. If you notice, the M's are in front and then the N is in the last two. So I'm going to break it into two groups. And in the first group, I'm going to pull the M out because it's common to both, and I get x plus y left over. And the second one, I'm going to pull an N out, and I have x plus y left over. Just like we did with the decomposition method, we have a factor of x plus y, and what's left is m plus n. C. This is like that middle one we did where A is the number in the front is just 1. So we're going to do our C method. The factors of 2 are 2 and 1. And if we add them, we get 3. So this one's just a simple A plus 2, A plus 1. D, again, this one has a number in front and I can't divide everything by 3. So I'm going to do that decomposition method that I explained in the third example. So 3 times 3 is equal to 9. And if I wanted to find two values that equal 9, but also add up to 10, I'm going to do 9 and 1. And so I'm going to decompose that 10x. So I'm going to get 3d squared plus 9d plus 1d plus 3. So I've just split that 10d apart into 9 and 1. And then I'm going to factor each of those groups. This one I can take a 3d out and I'm left with d plus 3. And this one I'm going to take 1 out and I'm left with d plus 3. And again, d plus 3 is common to both of them and I'm left with 3d plus 1. So that's how we do question D. E, I'm going to divide all of them by 4 first because they all have 4 common to them. So if I divide 4x squared by 4, I get x squared left. 8x divided by 4 is just 2x, and negative 12 divided by 4 is negative 3. And then you can think about, am I able to come up with two numbers that give me that? So negative 3 is going to be negative 3 times a positive 1, or positive 3 times a negative 1. This one will give me my plus 2 because 3 minus 1 is 2. So we'll get 4, x plus 3, x minus 1. And the last one, those can't divide all those terms by 2, but I can take an x out. So I'm going to pull an x out, and I'm left with 2x squared plus 5x minus 12. And then I'm going to do the same method as our last, so our decomposition method. 2 times negative 12 is negative 24. So we get negative 24, and I'm going to find numbers that equal plus 5. And if you know your multiplication tables, I know that plus 8 and minus 3 will do the trick. So I'm going to decompose that into 2x squared plus 8x minus 3x minus 12. So the 8 and 3 come from the 5. And then I'm going to factor these two and these two to give me, I'm going to pull a 2x out of this one to get x plus 4. And I'm going to pull a negative 3 out of this one and get x plus 4. This is the common factor, so we get x plus 4, and 2x minus 3. And that is all of those factored. If I went a little too fast, I'm trying to keep the video shorter, but you can always go back, slow it down if you want, or pause it to see just exactly what I did, or try them first before try them on your own before coming back to it to see exactly what I did. Either way, there you go. That is factoring polynomials. Tomorrow I'm going to do a particular special factoring of difference of squares. Anyways, I'll see you guys later. Bye.